Very good morning, one and all. Today, we are going to solve a simple problem in a Norton's circuit. Take down this problem. In a network shown in the figure, calculate the current through load resistance RL by using the Norton's theorem. So here two loops are there. So where is the load resistance? Load resistance is here 5 ohms. That is across the A and B point. What is the first step? First step is to remove the load resistance RL across the points A and B. That is the first step. So first we removed the load resistance. After that, we need to short circuit the. So we need to find out what is the short circuit current over this point, or otherwise Norton's current. Now we short circuited this particular. Now we need to find out what is the current to this point. So in this circuit, so there are two methods are there. You can also go with the loop analysis and find out. So what I did is I'm just reducing this. Okay, reducing this because this is short circuited. No, so now this 4 ohms and 6 ohms are in series. Okay, this 4 ohms and 6 ohms. So it becomes 10 ohms here. So I'm redrawing the circuit here 10 ohms and 10 ohms. I'm redrawing circuit. Now these two 10 ohms are in parallel. Two resistance are in same in parallel means it is 10 divided by 2. So it is 5 ohms. Now all this 5 ohms are in series. So 5 ohms series with 5 ohms again with 5 ohms. So just the equivalent circuit is 5 plus 5 plus 5. That is 15 ohms. So now 30 volts and 15 ohms. Now we can easily find out the current. So current is equal to V by R equal to. Okay. So current is, so here voltage 30 volts divided by R equivalent 15 ohms. So current flowing to this particular um, um, battery sources, that is 30 volts battery sources, 2 amperes. Now we need to find out what is the IN over here. So simply by using the current division rule, we can easily find out. So current division rule, so opposite resistance divided by total resistance. Opposite resistance is what? 10 ohms divided by total resistance is what? 10 plus 4 plus 6. 10 plus 4 plus 6 into the current flowing to this particular loop. So current flowing this particular loop is 2 amperes. So now easily we found out what is the IN over here. Or otherwise you can go with the mesh analysis and also you can find out the IN. So that is your wish. We want only the what is the current flowing to this particular loop. So IN is 1 amperes. Now we need to find out what is R. So Rn, what is the rule to find out the Norton's resistance? So Norton resistance short circuit the voltage source and open circuit the current source. So here only one voltage source is there. Just we are short circuiting and finding out what is the Rn over this point. Now I'm redrawing the circuit to find out the Rn. So short circuit the voltage source. See, here I am going to find out the Rn. Now this 5 ohms and 5 ohms are in. So 5 ohms and 5 ohms are in series or parallel. So it is in series. Okay. So now this is 2 are in series means this is 10 ohms. So 10 and 10 ohms, okay, and 4 ohms and 6 ohms. Now 10 and 10 ohms are in parallel. 10 and 10 ohms are in parallel. Two resistance are in parallel means the resultant is that resistance divided by 2. So 10 divided by 2 is 5 ohms. So 5 ohms, here 4 ohms and 6 ohms. Now we need to find out Rm. So now all three are in series. So 4 ohms series, 5 ohms is in series, and 6 ohms are all three resistance are in series. So all three 5 ohms, 4 ohms, and 6 ohms are in series. So Rn is nothing but 5 plus 4 plus 6. So that is 15 ohms. Now we need to draw the Norton's equivalent circuit. How to draw the Norton's equivalent circuit? So IN we found out now that IN and Rn we found out that Rn should be in the parallel. Okay, so we need to current IN, we need to connect IN and Rn should be in parallel. And the first thing we open circuited the load resistance. So that load resistance also we are adding over here. Now we need to find out what is the IL over particular this point. That is the question. So current through the load resistance IL is nothing but opposite resistance 15 divided by total resistance 15 plus 5 into this particular um, uh, current flowing this particular loop. So that is nothing but Rn divided by Rn opposite resistance is Rn divided by Rn plus RL into this I. So that is by current division rule. So IN is what? 1 amperes, and RN is 15 divided by 15 plus 5. That is 20. So if you simplify this, we are getting the load current as 0.75 amperes. So this is the answer for this particular question shown in the figure. So they asked what is the load resistance, load current across the particular load resistance. So that we found out by using the Norton's theorem.